Hey guys, before you go further into this class lesson, please don't forget to subscribe to this mathematics channel. Hope you all enjoy watching this class lesson. Please like, subscribe and share this video. Thank you.
Hello everybody, welcome to my class. Today I am going to discuss about caste rule in trigonometry. So the word caste has been composed by the letters C, A, S, T. Here C stands for cosine, that means cosine is positive. A stands for all, that means all trigonometrical ratios are positive. S stands for sine, that means sine is positive. And T, the letter T stands for tangent, that means tan is positive, negative. So let's see now how it is. So here you can see caste rule in trigonometry. Here C stands for cosine, positive. A stands for all positive, that means sine, cos, tan and their reciprocals such as cosec, sec and tan. S stands for sine positive and T stands for tangent, that means tan positive. So let's check what happens here. For example, suppose that this is a unit circle. Unit circle means its radius is 1 centimeter or 1 meter, or in general you can say this is of 1 unit, that means radius of the length is 1 in this case. So let's suppose that here this is angle A, which is made by the line OP1 with x-axis along this circle. So here, for example, let's suppose that if you drop a perpendicular here on this line, then it will be 90 degree, and then you know that sine theta equal to P by H, cos theta equal to B by H, and tan theta equals to P by B. That sort of thing we have to apply here. So for example, I am interested to find this length. That means if you say this as M, that is the foot of the perpendicular, then what is the length of M? That means the length of M will be the x coordinate for the point P1, and the length PM will be the height from x-axis to this point. That means PM will be the y coordinate for this point P1. So for example, let me check for cos A. So you can say here cos A equals to B by H, that means base by hypotenuse. So here you can see that base is written as PM, or you can say that the x coordinate, so this is x, and H is the unit circle. You can say that means H is 1 in this case, and hence you can say that x equals to cos A. That means x coordinate is cos A here. And again you know that sine A equals to P by S, that means perpendicular by hypotenuse, and then P value you can say that it is PM, or PM is, you can say in general that is Y, that means in place of P you can put Y, and in place of H is again 1 centimeter, that means 1, and hence you can say that Y coordinate is going to be 1 times of sine A after cross multiplication, so it is sine A, and hence you saw that here the x coordinate is cos A and the y coordinate is sine A over here. Then what about the tan? Tan means you know that if you would like to find tan A, you can do in 2 ways. Is that it is the ratio of this is P by B, perpendicular by base. So here the perpendicular is P1M. So P1M is in fact y coordinate, and base is AM. AM is in fact x coordinate, and y coordinate we have just seen that it is sine A, so we can put here sine A, and then x coordinate we have cos A, you can see here, and here also x coordinate as cos A, so we can write here cos A, and this is true that if you divide sin A by cos A, then it will be tan A. But what did you see over here? We talked about here it is sin A, cos A and tan A also. We see that all the values for cos A, sin A and tan A are positive, and therefore this is the first quadrant. This is the first quadrant. I'm not talking of this sector only. First quadrant means start from x-axis to first time you reach to the y-axis. Alright, so this is called the first quadrant, and in first quadrant you saw that sine is positive. Yes, here you can see sine is positive, and also you saw that cos is positive, as well as you saw that tan is positive. So definitely they are reciprocals. For example, reciprocal of sine is cosec is positive, and reciprocal of cos is sec is positive, and reciprocal of tan is cot is also positive. Okay, therefore we can say that here all trigonometrics ratios are positive. That means the values of all the trigonometrics in the first quadrant is always positive. That means we saw A in the first quadrant. A means all positive, means all trigonometric ratios values are positive in the first quadrant. Now let's check in the second quadrant what happens. So this is the second quadrant we are talking of. So let's draw a perpendicular on this line x-axis, and suppose that this is angle A. Alright, so we are taking the equal angle A. In this case we can take angle x, angle theta, whatever you can denote the angle for. So in this case, let's see what is the coordinate for the point P2. That means here it was at the position P, one particle, and that particle is now in the second quadrant at position P2. We'll check that what will be the value of x and y coordinate of P. So here in this triangle you can say this is M, then you can say this as M dashed. Alright, and then in the triangle P2 M dashed O, you can see that this is again the unit circle. That means its radius is 1. That means this sort of hypotenuse is 1. So here we talk first about x coordinates. So we know that cos A equals to B by H again, and B in this case is OM dashed. OM dashed is along the x-axis, that means negative x-axis in this case. So we can write here minus x, and H is P2M dashed. That means this is the S means OP2. OP2 is the hypotenuse, and hypotenuse values is 1 because this is a unit circle. So you can write here 1. Even if you don't take the unit circle, you can take with any length. The things will work, but it will be even better if you take the example of unit circle. So we found the x coordinate at this point as x equals to, this negative sign will be transferred to another side by cross multiplication, and then this will be minus cos A, and then we search for y coordinates. That means P2M dashed. So here we use sine A. Sine A means at this time we are using the angle A in the second quadrant. So sine A equals to P by H, and P is in fact along y-axis, that is M dashed P2, and this is in fact the y coordinate of this point P2. So P means here it is you can say y for this, or you may also write M dash P2 or P2 M dash, no problem. And H is again here 1, so this is 1, and then you found the y coordinate in this case is as this is H, means in place of H you can write 1. Alright, so y equals to, now it is sine A. So therefore you could see at the point P2 the coordinate x coordinate for this point P2 in the second quadrant is minus cos A, and the y coordinate is plus sine A. That means what we have found actually, that cos is negative. In this case we found cos is negative. but we found sine as positive. Alright, so let's see what happens for tan. So if you talk about tan A in the second quadrant I am talking of, so sine A, you know that sine A means it is tan A means it is sine A by cos A, but here in this case you can see that, or you may do this way also in order to find tan. So you divide here, or you can just write down here tan A equals to P by B, and P in this case is Y, but B in this case is negative X, so that you can write here minus X and take this sign minus out, and P means it is Y, so Y is it is, or you can just write in general Y by X, so you can say it is Y means it is sine A, so we can write here sine A, and X means it is in fact it is minus cos A, so we can write here minus cos A. Now take this sign outside of this ratio, so sine A by cos A is going to be tan A. That means what we have found in this case is that you found that cos is negative and also tan is negative, but sine is positive. That means in the second quadrant you can say that sine is positive. Okay, sine is positive means rest of the other trigonometrical ratios are negative. You can see that only sine is positive in the second quadrant, but cosine is negative and also the tan is negative, and hence their reciprocals are also negative. For example, if cosine is negative, then sec is also negative. If tan is negative, that means 1 by tan, that means that is cot A will also be negative, and here sine positive means its reciprocal cosec will also be positive, because cosec A equals to 1 by sine A, as sine A is positive, therefore cosec A is also. Third quadrant we found tan is positive. Finally, let's check in the fourth quadrant. In the fourth quadrant, similarly you join this point, so that here it will be the foot of the perpendicular, and the figures are not to the scale, so you can consider this as perpendicular here and this angle as A. Then let's check that what would be the x and y coordinate in the fourth quadrant. If you apply the same sense over here, you will find that the x coordinate is cos A and the y coordinate is negative sine A. That means what you could see here, that cos is positive but sine is negative in this case. And let's check for tan. So tan A in the fourth quadrant, I am talking here with respect to angle A from this figure. So tan A equal to P by B, it is P by B. So let's check here, perpendicular is the negative y, alright, and this is the y coordinate, is already here. This is minus sine A, you can write here minus sine A, and B means it is the x coordinate, so x coordinate is already here plus cos A, so you can write here plus cos A. And then what you got actually, that P by B ratio as in this quadrant as minus tan A. That means what did you get in the fourth quadrant is that only cosine is positive, but rest of the trigonometrical ratios sine and tan are negative. So we saw that in the first quadrant, you can see in this area, okay, that all trigonometrical ratios are positive, and in the second quadrant sine positive, that means rest of other trigonometrical ratios are negative except the reciprocal of sine, which is cosec. And in the third quadrant tan is positive, and in the fourth quadrant cos is positive, that means rest of the trigonometrical ratios are negative over here. So you must first understand this sort of thing, and then do remember. That will help you solving problems in trigonometry. Let's now how we can relate one angle to another angle, and we'll see that how the trigonometrical ratios change. So here in this case we are going to talk about sine 90 degree. 90 minus theta means here it is 90 degree minus theta, cos 90 degree minus a, and this is tan 90 degree minus a. We can also say theta also. So in this triangle you are clear that this is the x coordinate and this is the y coordinate. So x coordinate is cos a and y coordinate is sine a. And let's check what will be the x and y coordinates for this point P dash. So we are talking of 90 minus theta, 90 minus a. That means the whole thing is here, it is 90 degree. So up to here only if you talk, this angle is going to be 90 degree minus a. Okay. So for example, if you are talking of the x coordinate, and let's draw a line perpendicular to this x-axis, and then we'll see that what will be the y coordinate and what will be the x coordinate of this point P dash. So here in this case you can see, like if you are talking of 90 minus theta, this angle is 90 minus theta up to from here to here, it is 90 minus a. Sorry, I'm always talking theta. So here it is a. So in this triangle you can see that you can say here it is m. So in the triangle I'm talking of O P dash m. So here if you talk about cos a, means it is cos 90 minus a. Cos 90 minus a is, you know that this is b by h, and we are again taking the unit circle. That means radius of this circle is 1, and hence its hypotenuse will be 1 here. So b in fact is x and h is 1. So x coordinate of P dash is cos 90 minus a. Similarly, we talk about sine 90 minus a, means 90 degree minus a, is P by h, and P in fact is this height, that means the y coordinate. So you can write y coordinate, and h is 1. So y coordinate we have found as it is sine 90 minus a. So let's see here that in place of x coordinate we have cos 90 minus a, and in place of y coordinate for the point P dash, this is sine 90 degree minus a. Let's relate this sort of thing with the another angle a. We are taking the same amount of angle a over here with respect to this angle POX. Alright, so let me talk in this triangle now. So m it is, then you can write here m dash for example if you like. So let's talk in triangle P dash O m dash you can say, or P dash m dash O you can say. Okay, so right angle is m, so you can write P dash m dash O, and in that triangle let's talk about this triangle. What will be the x value? X value in fact is this perpendicular for this angle A. Alright, so what you can write here is that in this case if you write sine A, that is going to be P by S again, P by S again, but now this is in the triangle P dash m dash O, which is here P dash m dash O. Alright, and you can see along this way this is parallel to the x-axis, that and it is stopped here. That means definitely m dash P dash is the x coordinate for the point P dash. So here perpendicular is x. In this case this x and this x are different now, but are the same, but they have been interpreted in different ways. And by 1, that means x coordinate by taking the reference of triangle P dash m dash O is sine A. And if you talk about cos A, in that case cos A is defined as base by hypotenuse, and base you can see that this is along positive y-axis, that is m dash O. Alright, and m dash O is equals to m P dash, which is the y coordinate for the point P dash. In that case what you can say here is that B as the y coordinate, and then H is the radius of the unit circle, which is 1, and hence y coordinate in fact what we have got as cos A. So if you compare point P and P dash, we have the things like in opposite. So what we have got in this case is that in place of x you can write here now sine A, and in place of y you can write, look at here, y equals to cos A, so you can write here cos A. Now compare this and this sort of thing. Both are the x, so x equal to x, alright. So what you can see here is that this is x and this is x. So what it is found that cos 90 minus A, so therefore you can say that cos 90 degree minus A equal to x, but x in this case we have found as sine A, so this is sine A, and you can see that sine 90 degree minus A, sine 90 degrees minus A is y in fact, okay, is y in fact, and here also y has been found as cos A. So now we have to remember is that sine 90 degree minus A equals cos 90 degree minus A equals to sine A, and sine 90 degrees minus A equal to cos A. Alright, then what about tan 90 degrees minus A? Just use formula for tan, it is sine 90 degrees minus A, because this is sine theta by cos theta in general, and this is cos 90 degrees minus A. Alright, so sine is defined that way, but just now we have seen that sine 90 degrees minus A equals to cos A, so in place of sine 90 degrees minus A you can write here cos A, and cos 90 degrees minus A, just now we have seen that this is sine A, so you can, in place of cos 90 degrees minus A, you can write here sine A, and therefore it is found as cos A by sine A is cot A. Okay, so note that cos 90 degree minus A is sine A, sine 90 degrees minus A is cos A, and tan 90 degrees minus A is cot A. We saw that in the first quadrant here, sine 90 degrees minus A equals to cos A, cos 90 degrees minus A equals to sine A, and tan 90 degrees minus A equals to cot A. And similarly you can check for their reciprocals also. Reciprocals in the sense that if it would be cos x CSC, that means cos x, this is 90 degrees minus A, that means it will be 1 by sine 90 degrees minus A, and you know we have here now sine 90 degrees minus A is cos A, so you can write here 1 by cos A equals to, this is sec A. Alright, so similarly you can find for sec 90 degrees minus A will be equals to cosec A, and yes, it is cot now. We cot 90 degrees minus A will be equal to tan A. Similarly, we shall now talk about sine 90 degree plus A, cos 90 degrees plus A, and tan 90 degrees plus A, and the similar way we can see for the 90 degrees plus A angles for their reciprocals. So here sine 90 plus A means in the first quadrant, if you start to count the angle from this x-axis, and then if you go up to the first quadrant, this will describe 90 degree, but we are interested to see the value for or the term for sine 90 degrees plus A, cos 90 degrees plus A, as well as tan 90 degrees plus A. That means any angle more than 90 degree will fall in the second quadrant. Alright, so here we have this angle as A, that means equivalent to this angle. So here we are talking of up to here 90 degree and then plus A up to here, so all together we are talking of this angle. Okay, So let's check what happens here in this triangle. Now this is not necessary to give the name of this triangle. If you are interested, you can write M or something like that, and you say in this triangle, like this is right angle, and go ahead. But you can see it directly also now. So I'm talking in this small triangle here now, that if I talk about the x coordinate, for example, x coordinate is given by this line. You can see in the slightly yellow color. All right. So first of all, we use sine and cosine. So let me use sine. So sine A in this small triangle is P by H, and still this is a unit circle having length 1 centimeter, or you can say in general 1 unit, so that its hypotenuse length is also 1 unit. So let's check what is the perpendicular here. So for this triangle, perpendicular is P dash M, and P dash M belongs to x. That means x is negative in this case because it is behind the y-axis, and h is 1, and therefore you can say that x equals to minus sine A. That means we obtained the x coordinate as minus sine A, that is negative sine A. All right. And let me check for y coordinates. So it is cos A equals to base by hypotenuse, and base for this triangle is along the positive y-axis, so you can write here y, and h is, in fact, it is again radius of the same unit circle. This is 1 centimeter, so you can write here 1. So you have y coordinate as cos A. All right. So what we have got in this case is we have got y coordinate as cos A. Now let's see what happened when you applied 90 degrees plus. Okay, so after being found the x and y coordinates for this point P dashed, when it subtends angle A about the y-axis towards left of it. Okay, but in this case we will not go to that much of geometrical details, although we can, and we have it here, but we can just use some sort of idea that what happened to the coordinates x and y coordinates when it was P and when it is P dashed. So let's check here that if you talk about sine 90 plus A for this position, so at this position you saw when it is sine A, now that is the y coordinate, and here also this is the y coordinate, and because of this 90 plus A, it has been now turned to cos A. So you can write here this is cos A, and you know that this we have just seen that in the second quadrant sine is positive, so we got the positive value for sine in terms of cos A. Now what happened to this x coordinate and over here x coordinate when it was A, and now when it is 90 plus A, that cos A has been turned to negative sine A. So we can write here that cos 90 degree plus A equals to minus sine A, and you know that only the sine and its reciprocal are positive in the second quadrant and rest are negative here. So value of cos in the second quadrant, you saw here that this is negative sine A. Now what about tan 90 plus A? Tan 90 plus A means you can also use this sine 90 degree plus A over cos 90 degrees plus A. No need to go to the figure again, but if you like you can work out for tan 90 degrees plus A also, but it is not required. And we have seen that sine 90 plus A is cos A, and cos 90 plus A is minus sine A. So it is minus cos A by sine A, so it is minus cot A. Alright, so in this way we can find the values of trigonometrical ratios with angle 90 degrees plus A, and also we have to see whether or not this is the meaningful, because sine is positive here in the second quadrant, so we got it is positive, and cos is negative, so we got the value of cos 90 plus A is negative, and also tan is negative in the second quadrant, and therefore tan has also negative value in terms of cot A. Alright. After being explained for the angle 90 degrees plus minus A, now we'll see for the angle of the trigonometrics for 180 degrees minus plus A. Okay, so let's talk about first of all, we have, this is the point, and after some times the particle is at this point P test, which is in second quadrant, because 180 degrees. So up to here you can see here, up to here it is 180 degree, because this is a straight line. And now we talk about sine 180 degree minus theta, for example. That means we talk from angle from here up to here only. So this angle in fact is sine 180 degree minus 1. That means by 180 degree minus A, 180 degree minus A, the position of P will be P dash in the second quadrant, because 180 degree up to 180 degrees in the second quadrant, but negative, it is minus A over here. That means it is still in the second quadrant. So this angle is here. So we relate the angle A in the first quadrant to the second quadrant by taking a angle difference over here. Alright. So in this case, let's consider for this angle. You know that at P the x coordinate is cos A and the y coordinate is sine over here. Now we check for P dash, what would be its x coordinate and what would be its y coordinates. Alright, look at here now. When it was A only, alright, here it is sine A as the y coordinate. Now what happened when it was now, when it is now 180 degrees minus A, the sine A is now become sine A. So sine 180 degree minus A is still it is sine A. Now what about this cos A? So here it is positive cos A. So if you talk about cos 180 degrees minus A, so you can say that here when it was A only, we are taking A only, then x coordinate was cos A. Now when we turn this point up to here by the angle 180 degree minus A in the second quadrant, what we have got actually that this cos A is, now it is minus cos A. So what you can write here that cos 180 degree minus A is minus cos A. And also see that here that as we are talking the values or the term in the second quadrant, and you know that in the second quadrant sine is positive, so sine 180 degree minus A is found positive term here, positive sine A, and other ratios like cosine and tangents are negative. So here in this case we saw that the cos value is negative cos A. Cos A, and so that it is minus outside, and sine A by cos A is tan A. So in the second quadrant you know that only sine and cos A are positive but tan is negative, and we found the same over here. But what happens while we are going through 180 degree minus A, sine is sine, cos is cos, and tan is tan, only there are few changes in their algebraic sign. And now similarly we can talk about sine 180 degrees plus A, cos 180 degrees plus A, and tan 180 degrees plus A. That means start from here and up to here, this is 180 degree, and plus A means the surplus angle that will definitely go to the third quadrant. Here also we check for x coordinate as well as for the y coordinates of this point. Now let's check what happens here. We will do the similar work that we did over here. So here in this case, for example, if I am finding sine 180 degrees, now plus it is angle A, let's see what happens when it was A. So in place of sine it was sine A, in place of y coordinate it was sine A. Now this sine A has become negative sine A, you can say. So sine 180 degrees plus A is negative sine A. And similarly you can check for cos 180 degrees, and which is the x coordinate of this p dash. And similarly when it was a only, the x coordinate was cos a. Now when it is 180 degrees plus a, the x coordinate is now it is negative. Okay, this is negative cos a, so that it is minus cos a. All right. And what about tan 180 degrees plus a? So here you can see that tan is ratios of sine and cosine, so it is minus sine a. You can see sine 180 plus a by cos 180 plus a, so it is minus sine a, and this is minus cos a, and negative sign they will cancel each other, so that it is sine a by cos a is tan a. So you know that in the third quadrant tan is positive, that means cosine and sine are negative over here, and same sort of situation we have found here, because 180 degree plus a lies in the third quadrant, and in the third quadrant we found sine as negative and also cosine as negative, but tan as positive. So we are talking in terms of 90 degrees, 180 degrees. So those are actually the standard values in trigonometries, and similarly 270 degrees, and later we'll talk about 360 degrees. So those are also the standard values in the trigonometry, and rest other values within 360 degree or beyond 360 degrees we can deal accordingly. So here now we are talking of sine 270 degrees minus a, and same for cos and tan as well. So 270 degree means up to here this is 90 degree, and up to here it is 180 degree, and plus 90 if you add in 180 degree, that means we have completed the third quadrant. But when we are talking of 270 degrees minus a, then definitely we are in the third quadrant, because up to here it is start from here and up to here we have 270 degrees, and minus a means it is a, that means inside this third quadrant. All right, so let's check what happens. So p dash, you can say it is m as the foot of the perpendicular over here. So this is angle a and this is angle a here. So from here up to here, if you check, this would be 270 degrees minus a. So because up to here is 270 and up to here a is taken off, so it is minus a, and this is in the second quadrant, remember it. And now we'll find the x and y coordinates for this p dashed. So first of all, in this triangle, so in triangle we can talk in the triangle OM, or you can name anything for the foot of the perpendicular or for the other vertices, OMP dashed. Okay, so here let's start from cos or sine, whatever you like. So cos a means we are talking of this angle a in this triangle. So cos a is b by h, and hypotenuse, this is the radius of the unit circle again, so hypotenuse must be 1 here, and b means in the sense that you can say that cos h and b by h. So for this angle a, base is OM, alright, and OM is along y axis. So what you can write here, this is minus y. So y coordinate is, after taking minus to the other side, this is cos a. Alright, y coordinate. Alright, now let's talk about sine 270 degrees minus a values. And you can see here is that when it was a over here, x coordinate was cos a, but by the rule, if you say 270 degrees minus a, now it is at point p dashed, and its sine has become negative cos. Alright, so y coordinate is sine a over here when we consider this angle, and now when it is at p dashed, where where there is 270 degrees minus a, then if it is sine a, now sine a has been turned to negative cos a, so we can write here minus cos a in the third quadrant, and then you'll find that this will be the cot a. You may also work out yourself here. This is cot a, and you know that in the third quadrant tan is positive, so we got tan in terms of positive cot a. Similarly, let's see about sine, cosine and tan 270 degrees plus a. Alright, so up to 270 degrees we are up to the third quadrant. Now 270 degrees plus a means we have advanced to the fourth quadrant over here. So about here we drop the perpendicular on this y-axis, so this is 90 degree over here, and now we are interested to find the coordinate of p dashed in the. Let's talk about now sine 270 degrees, because we are talking of plus a over here, so you can write here sine 270 degrees plus a. So when it was angle a, the y coordinate was sine a, and when it is now 270 degrees plus a, this sine now became, you can see that negative cos a, that is minus cos a. And similarly you can see that cos 270 degrees plus a equals to, now when it was p, then it was cos a according to this angle a. Now when it is 270 plus a, so x coordinate is, now you can see here that this is sine a, that is positive sine a, so we can write here sine a. Alright, so we have already seen that in the fourth quadrant cos is positive but sine and tangents are negative, and therefore what you can find here that yes, tan 270 degrees plus a equals to sine 270 degrees, that is minus cos a, and then cos 270 degrees plus a is sine a, so it is minus cot a. And similarly let's now talk about sine 360 degrees minus a, cos 360 degrees minus a, and tan 360 degrees minus a. Alright, so here we'll do again the same work at this point. So you can say that the whole circle is 360 degrees, but we are taking from here up till here as 360 degrees minus a. So let's check in this, you can, if you like, you can write over here m, because they have the common foot of the perpendiculars here, because these two angles are equal we are taking. So here in this case in triangle we can say it is O, M and P dashed, not P, in P dashed, and this sort of thing is already known. So here it is, you can find it is sine A. Sine A means we are talking of this angle A. Alright, so now let's check sine 360 degrees minus A equals to what happens here. So when it was sine A in the first quadrant, you know, it was sine A, y coordinate. Now this sine A has become negative sine A, and you know in the fourth quadrant only cos is positive, so it is minus sine A. Minus A is minus sine A, so you can write here minus sine A, and then cos 360 degree, because sine 360 degree minus A is tan 360 degrees minus a is sine 360 degree minus a by cos 360 degrees minus a. So in place of cos 360 degrees minus a we have cos a, so we can write here cos a, and we see that it is minus sine a over cos a is tan a, and we found tan a as value of tan is negative in the fourth quadrant. So in this way we can develop the relation between 360 degrees minus A and this angle A. Let's now talk about for 360 degree plus A. So up here you can see we'll do the same work. So what happens here with this complete circle, up to here again it is 360 degrees, and but up to here plus A means we are taking the same angle plus A, then we are again to the point P, that means P and P dash will coincide each other. So directly from this figure we can say that sine 360 degrees plus A is sine A. Alright, because there is no change in y coordinate. When it was A, then it was sine A. Now when it is now 360 degrees plus A, that is it is again in the first quadrant, so sine A is itself sine A. And similarly cos 360 degrees plus A, there will be no change, so that will be cos A again. And then what about this tan A? So tan 360 degrees plus A means this is the ratio of sine and cosine, and hence this is sine A by cos A, and that will be tan A. Let's now summarize the facts over here. So we saw that sine 90 minus A equals to cos A, cos 90 minus A is sine A, sine 90 plus A is cos A, cos 90 plus A is minus sine A, tan 90 minus A is cot A, tan 90 plus A is minus cot A. And similarly you can see that here for 270 degrees minus and plus A. And then you can just check back to here. It is sine 180 degree plus A is minus sine A, because this is in the third quadrant, and in the third quadrant both sine and cosines are negative here, but tan is positive. And 180 degree minus A, this is the second quadrant, sine is positive, but rest of the trigonometrical ratios cos and tan are negative out there. And this is in the third quadrant again, sine is negative. 360 minus A, this is in the fourth quadrant, yes. So sine is negative and tan is negative, but cos is positive here. But 360 degree plus A means we are again back to the first quadrant where all trigonometrical ratios are positive. So our results are like this. Okay. And one another feature what you can observe here is that, let's see here, this is 90 minus A. So let's check for n times of 90 degrees plus minus A. Alright, so when n is odd in the sense, in this case we check for n equals to 1 and 3, maybe for 5, 7 you can also check for, but we did for only n equals to 1 and 3 till now, but it applies to the other odd values of n as well. So here in this case, for example, if you are going to write 270 minus 270 degrees minus A, that means this is 3 times of 90 degrees minus A. Alright, that means odd number times of 90 degrees minus A. So where you find the given trigonometrical ratios are given in the form of odd number of times the 90 degree plus minus A, then what happens? Sine becomes cos and cos becomes sine, and similarly tan becomes cot. Alright, and here also this is 1 times of 90 degree, that means it is odd number times of 90 degree minus A, that means sine becomes cos and cos becomes sine. And we check for this sine outside this cos, sine, and here cot, that depends on which quadrant the trigonometrical ratios lies in. Okay, and next you can see here at this point again we check for n times of 90 degrees and plus minus of angle A like this, and when n is even number, even number means n can be like 2 and 4 for example. Alright, so for example if you are going to say it is 180 degrees plus or minus of A angle, that means it is 2 times of 90 degrees plus minus a. That means this is even, n is even number of time than 90 degrees plus minus a. And similarly, if you would like to check for 360 degrees, here minus a and plus a, so 360 degrees plus minus a, in that case it is 4 times of 90 degrees. That means 360 degrees is 4 times of 90 degrees and plus minus a. Then you can see what happens, that when this sort of angle combination is according to the odd even number times the 90 degree and plus minus a, then what happens, sine remains sine, cos remains cos, and tan remains tan, and this negative sign or positive sign, it depends on which quadrant the particular trigonometric ratio lies in. So always note that whenever you encounter with odd number of time 90 degree, then make sure that sine is going to convert in cos, and cos in sine, and tan in cot. But if n is even number, then what happens, sine remains sine, cos remains cos, and tan remains tan. That you can remember, but you have to take care of the sign of this resulting trigonometrical ratios value. It depends on which quadrant that particular trigonometrical ratio lies in. Okay, so this is all about. Now, based on the knowledge that we have gained through the cast rule, let's see some examples where the cast rule is applicable. So here are some examples that use cast rule. So here in this example you can see that solve tan x equals to 2.1 for all possible values of x where x is between 0 to 360 degrees. Alright, so here you have to find all the possible values of this equation tan x equals to 2.1 within the given range of values of x. So here it is given that, let's start from the given, like it is tan x equals to 2.1, and then you see that x equals to tan inverse of 2.1. alright, and therefore x equals to, let's go to the calculator. So in the calculator you have to put the calculator in the degree mode, it's already here. Then you have to find inverse of tan, then it is 2.1, close this bracket, and this is 64.536, so you can take that nearly equal to 64.5 up to one decimal place, so that we can write x equals to 64.5 degrees. So this is the first value that we obtained, and this is definitely in the first quadrant. This is 64.5 degrees. Alright, so this is 64.5 degrees, and this sort of the first value is called principal value of x, which is in degree here. And now this is not only enough to calculate, because you have to see for all possible value of x in the domain 0 to 360 degrees. You have to see here. Then you have to see that it is tan x is 2.1 and this is a positive number. Then you have to check for where tan is positive. So in the first quadrant they are all positive. Alright, so tan, one of the tan value is here over in the first quadrant, so that one of the answer is 64.5. Now you know that also in the third quadrant here you can see tan is positive, but cosine and sine are negative here. So we check for the positive value of tan x in this third quadrant, and let's take one angle over here equivalently in the third quadrant. So by vertically opposite angle case, here it is 64.5, and if you start to count from here up till here, then it is 180 degree plus 64.5 degrees. Alright, and also you know that tan 180 degrees plus A equals to tan A, and here A means the principal value. So in the first quadrant in general, so it is tan 180 degrees, and here it is 64.5. so you can write here 64.5 equals to, means that should be equal to, that must be equal to 64.5. so therefore another possible value of x in this case will be 180 degrees plus 64.5. now go to the calculator again. So calculator is ready here, and then you put here plus 180 degrees in the answer, and it is 244.54 you can say, but up to one decimal place you can take up to 244.5, or if you would like to make even closer accuracy, in that case you can take it this up to the 3 significant figure, 4 significant figure, but that is not required unless it is asked in your question. But here in this case we take the easy value, so this is 244.5. so it is 244.5. so therefore the possible values of x according to the given situation in this case is x equals to, the first value is 64 and the another value is 244.5, where tan x is positive. That means tan x is positive in the first quadrant and only in the third quadrant, and therefore these two are the answers. This is also possible that in the third quadrant, so first we start from tan x equals to 2.1, and for tan x you can write cot 270 degrees minus A in general is 2.1, because, or you can write x here because the angle is x here. So you know that cot 270 degree minus x is tan x, so you can write this way also, and you can again write this cot as 1 by tan 270 degrees minus x equals to 2.1, and therefore tan 270 degrees minus x will be 1 by 2.1, and then you go to the calculator, and then in the calculator we can see that 1 divided by 2.1 is 10 by 21, so it is 10 by 21. You can write, you could write in the decimal form also, degrees, and finally it is so deduct it from 270 degrees now. So again we found this as 244.5 degrees. So this way also it is possible to find the another value of. Let's now this example which is related to the previous one. It was before, it was plus 2.1. now we are working with minus 2.1 over here. That means we say that for the negative value of tan x. So tan is negative in, you know that this is negative in the second quadrant and also in the fourth quadrant, but in the second quadrant tan is positive. So in this question, solve tan x equals to minus 2.1 for all possible values of x, where 0 is lesser or equal to x is lesser or equals to 360 degrees. So x is in degrees here. So in this case, this is good idea is that at first you take the principal value. So this is tan x equals to 2.1 in the positive sense first of all, and you found that in this case x equals to, it's already here now, x equals to 64.5. you don't need to calculate it again. So you have x equals to 64 0.5 degrees at the principal value, but we are talking of this tan x as negative, so we check in the second quadrant and also in the third quadrant. So if this is 64.5 degrees at the principal value over here, but we check for the value of tan x, value of x where tan is negative, so this is negative in the second quadrant. First of all, we check it here. So let's take this angle equivalent to this x, that is 64.5 degrees, and you can use the sense or the formula that tan, here it is up to here it is 180 in the half circle minus 64.5. so you can write here 180 minus 64.5 equals to tan 64.5, because you know that tan 180 minus 64.5 is, no, it is minus tan x, because in the second quadrant tan is negative. Alright, so therefore another possible value of x in this case is 180 degrees minus 64.5, and let's go to the calculator again. You can check 180 minus 64.5, and that's going to be 115.5. if you like, you can check also, check that whether or not tan 115.5 degrees equals to minus 2.5, not plus 2.5. you have to check for the negative value of tan x. So let's go back to the calculator, and in the calculator you put press tan, and then it is 115.5 degrees. so calculator is in degree mode, so make sure of that. And then it is minus 2.096, means it is nearly equal to minus 2.1. so the value of x at this point is, we have found that this is 2.09 and few more decimals, so this is nearly equal to minus 2.1, and which is true. So therefore another value of x is also 115.5. now you know that tan is negative in the fourth quadrant also. So in the fourth quadrants, let's take this angle as x, that is 64.5, where tan is negative, and then we calculate this angle. And you also know that tan in the fourth quadrant 360 degrees minus x equals to minus tan x. That means you have tan 360 degree, you can call a also, no problem. Yes, so a means the principal value, so principal value is here, you can see it is 64.5, and then that must be equals to tan minus tan 64.5. so therefore another value of x should be 360 degrees minus 64.5. so let's calculate it. So this is 360 degrees minus 64.5, and that angle is 295.5 degrees. And you must check that whether or not tan 295 degrees 95.5 degrees is minus 2.1. so let's check back to the calculator. So in the calculator, this is tan, we are checking this tan, and then this is 295.5. close the bracket and make sure that this is in the degree mode, and then we saw again that this is minus, near close to minus 2.01. that means after rounding off to one decimal place, you will have the value minus 2.1. so this value is also true, that is minus 2.1. so therefore possible values of x in this case, where x is from 0 to 360 degrees, are, first value we don't keep here because first value is for the positive tan, but for the negative tan we have to keep this value, so which are 115.5 degrees, and another value where tan is negative is, you can check here, this. Yes, so this is 209. And similar sort of work we will do with this example, where sin x equal to minus root 3 by 2 for 0 is less than x and less than 360 degrees. So sometimes it will be given in terms of less than, and sometimes in terms of less or equal to. So here also the main idea is that solve sin x equal to minus root 3 by 2 for 0 is less than x is less than 360 degree. Here also we first take the principal values for sin x. We don't keep the negative value at first. So this is divided by 2. You go to the calculator, your calculator value you can check here in the degree mode is that your x value will be 60 degrees here. So here let's take that the principal value as 60 degrees, but what we are actually working for, we are actually working for sin x equals to minus root 3 by 2, and that means sine is negative. So you have to check where sine is negative. Sine is negative in the third quadrant and in the fourth quadrant, but itself in the second quadrant and first quadrant sine is positive, so will not keep this principal value. However, this principal value will be a reference to find the value of sin x where sin x is negative. So let's go to the second quadrant here. In the second quadrant this angle must be 60 degree because these two are the vertical opposite angles. So first we check in the second quadrant is that we have to find this angle, that means 180 plus theta, 80 plus 60 degree here. So you know that sine 180 degrees plus 60 degrees equals to minus sine 60 degrees. Alright, otherwise you can go to calculator and check whether or not this sort of thing are equal, and also this is the formula based on sine 180 degree plus a equals to minus sine a. Alright, so therefore another possible value, or one of the possible value in this case is 180 plus 60, and then it is you add them, so it is 0 and this is 4 and this is 2, so this is 240 degrees. If you like, you go to the calculator and check whether or not sine value is negative. So this is sine of angle 240 degrees, yes, and it is minus 0.866025, that is equal to minus root 3 by 2. You can check in your calculator, so that this value is true. And now we work in the fourth quadrant where sine is again negative. So just we keep this value equal to this x, that is 60 degrees over here, and then we have to find this angle start from the first quadrant till the fourth quadrant where sine x is negative, and this is 60 degrees. So you again you know that in general sine 100, no, now it is 360 degrees minus a equals to minus sine a. That means we are in the fourth quadrant where sine is negative. So therefore you can say that the another value of x in this case is 360 degrees minus principal value a. Here the principal value is 60, so that this is 60. Okay, so that this is 300 degrees. And once again you can check this value that it is sine, and make sure that your calculator is in the degree mode, and then we are checking for 300 degrees, and then it is, yes, again it is minus root 3 by 2. So therefore we checked for all the possible values of x for which x is between 0 and 360 degrees, and these possible values are x equals to, one of the value is 240 degrees, and we don't keep this principal value because sine, it represents the sign to be positive. So this sort of value, so where sign is positive, are not taken into consideration here. And the another value where sign is negative is 300 degrees, and this is the answer. Let's now see here that instead of 0 to 360 degree, now it is only difference is that x is between negative 180 degree to positive 180 degrees. So rest of the process are the same like we did here, but only difference is that to read of the value according to the given range of value of x is different here. So in this situation, what you can see is that, so it is 180 degree, that means we consider 180 degree in anti-clockwise direction, that means it is plus 180 degrees. Okay, so this is the anti-clockwise direction. And negative 180 degree means we count it from below this x-axis in the clockwise direction. So whenever, this is tradition that when we take the angle along the clockwise direction, we keep it negative, and along the anti-clockwise direction we keep the angle as positive. So in this case again, your sine x is minus root 3 by 2, and your principal value you have 60 degrees that we have already seen earlier. So this angle is, in fact, it is 60 degrees. Now we have to work for where sine is negative. So you know that sine is negative in the third quadrant as well as in the fourth quadrant. So let's check here that in the third quadrant, just like we did earlier, so it is 60 degrees again. So in the third quadrant, what you can do here, that you have to get this angle. Okay, so from here to from here it is 180 degrees. All right, that means the possible value, one of the possible value of x is 180 degrees, and when you deduct this 60 degree, then you will have this angle in the clockwise direction. So you can write here minus 60 degrees, and you know that in the clockwise direction is just opposite to the anti-clockwise direction. So for the clockwise direction we keep all these angle in negative sign. So it is minus 120 degrees. And now yes, it is minus 0.86, that means it is minus root 3 by 2. So this is true. So this is one of the possible value for x in this equation. Now we work in this fourth quadrant here, that, and you take this angle equal to the x, that is the principal value, that is 60 degrees, and you know that this 60 degrees is measured in the anti-clockwise direction, therefore it is taken as positive. But here in the third quadrant it is taken as negative 60 because we measure here in anti-clockwise direction, and therefore another value of x is here minus 60 degrees, where sine is negative. So we checked for the third quadrant as well as for the fourth quadrant, but we will not consider the values of sine in the first and second quadrant quadrants where sine is positive, because it is given as minus root 3 by 2, which is negative number. So therefore possible values of x are minus 60 and minus 120, and these are the answers. In the same way, let's try this example. So this is a unit circle I am taking here, and the diagram is not to the scale, so these are only the reference diagram. So here again we take the principal value first. So here it is cos x equals to 1 by 2, even though this is minus 1 by 2. So first of all we find the principal value, and in this case you can see that cos x equals to cos inverse of half, that is again 60 degree over here, or otherwise you can go to the calculator and then you can check for cos half, and you'll find that when your calculator is in degree mode, is that this is 60 degrees. So value of x in this case is 60 degrees. Alright, and this is the principal value that we write over here in the first quadrant. So this is 60 degrees. But in this case, you can see that it is given that cos x equals to minus half. That means cos is negative, and you know that cos is positive in the fourth quadrant and in first quadrant. So we will not find the values of cos in the first and the second quadrant, although we have taken this as principal value in the first quadrant. So we check for the value of cos where it is negative. So you know that in the second quadrant cos is negative, and in the third quadrant also cos is negative, but here cos is positive, and here also in the first quadrant cos is positive. So we consider for the second and the third quadrant. So for example, if you are in the second quadrant, take this angle equivalent to the principal value, and here also you know that cos 180 degrees minus a or theta, anything you can write, which is that represents the angle is in the that presents the value of cos in the second quadrant, which is negative, and that is equal to, because this is even number times of 90 degrees, so cos remains cos, so it is minus cos a. Alright, that means it is cos 180 degrees minus a means it is the principal value, so we can keep this as 60 degrees, and this is minus cos 60 degrees. They must be equal, otherwise you can go to the calculator and check this. Check it out. Yeah, and then therefore you can say that one of the possible value of x in this equation is 180 degrees minus 60, that is 120 degree. If you like, you can go to the calculator again and you check for cos 120 degree, and this value is minus 1/2. So this is true. And now we try the value of x in the third quadrant. Alright, so what you can see here, instead of taking 60 degree over here, you take this principal value difference 60 degree over here, and also you can take it from 270 degree by using the formula, but I am taking it from here. So what you can see in the third quadrant, so in third quadrant, although this is not necessary to write, but it makes the thing clear, quadrant, you can you know that cos 180 degrees plus a means plus, I will keep, this is 60 equals to minus cos a, means here the principal value is a is 60 degrees. Alright, and therefore another possible value, and for x in this case is 180 plus 60, and that is equal to 0, and this is 4, and then 1 becomes 2, so this is 240 degrees. That means cos 240 degrees should also be minus half. So you can go back to the calculator. So let's check for cos 240 degrees is, again this is minus 1/2, that is minus half. So therefore this is true, and I think we have worked out for all values of x where x between 0 to 360 degrees where cos is negative. So therefore x equals to 120 degrees and 240 degrees. These are the possible values of x according to the given condition, and these are the answer. Similarly, for the same question, only the range of value of x is now is given in terms of minus 180 degree to plus 180 degrees, and we have just discussed about the positive and negative direction of measuring angle. So we'll use the same thing over here also again. So we have, you can see here that it was 60 degrees again, and only now we consider this sort of thing. And in the second quadrant cos was negative, and also in the third quadrant cos was negative, so this is 60 degrees. So let's check in the second quadrant. So here the value of possible value of x will be, this is 180 minus 60, so one value is 180 minus 60 equals to, this is 120 degrees, and this is just less than, this is less than 100 plus 180 degrees, so this value will keep where cos is negative. And also up till here, let's check that this is 60 degrees, but at this time we are not talking of 180 plus a or between from 0 to 360 degrees, but we are talking from negative 180. That means we measure this angle along this negative direction, which is the clockwise direction here. So with reference to this sort of thing, that means with reference to the negative 180 degrees, what you can say that the another value of x in this case is 180. That means from here up till here, from downward of this about downward of this x-axis up to here, it is 180 degree, but here it is 60 degrees. So from here up till here it is 180 minus 60 degrees. But in this case we are not measuring the angle along the anti-clockwise, we are measuring the angle along the clockwise, which is called the negative direction. So we put here negative sign here, and then this value is minus 120 degrees. Okay, so this value is going to be minus 120 degrees. So let's check what happens for minus 120 degrees and close it. This is again minus 1 by 2, and therefore this value is true. Why? For x equal to, even x equal to 120 degree and also x equal to minus 120 degrees, we got the same value minus 1 by 2, is because you can see here that cos minus 120 degree equal to cos 120 degree, because you should know that cos minus theta equals to cos theta. So that is the reason, and therefore these two are the possible values. So therefore the possible values of x in this case is minus 120 degrees and plus 120 degrees, at which the value of cos is negative, and these are the answers. Finally, let's try a complete question. So here you can see in example 4, solve 2 sine 2x equals to cos x, where 0 is less or equal to x is less or equal to 360 degrees. So you have to take care of the range of value of x given. Sometimes it is 0 to 360 degree will be given, and sometimes it will be negative 180 degree to 100 plus 180 degrees, or otherwise also you can understand if it is given more than 360 degree, then you have to advance again to the first quadrant throughout, and that sort of thing you can apply. Again, if you are in the first quadrant, then the same rule of cast will apply here. So we'll not talk much about that thing at this time. So here let's start from here, that it is given that 2 sine 2x equals to cos x, and that gives you 2 times of, you know that sine 2x is 2 sine x times cos x. This is a formula for sine 2x, and equals to cos x. And here take care, most of the students used to cancel the term, so please don't cancel the term, because we require as much of the information we can. So now it is 2 times 2 is 4, and then this is sine x, and then it is cos x is here, and if you transpose this to the left, it's going to be minus cos x here equals to 0, and then take out cos x common, and inside you will have 4 sin x minus 1 equals to 0, and therefore you can see that from here, from this equation, cos x equals to 0. You have equation 1, and then you have 4 sin x minus 1 equals to 0. You can call it equation 2. So using equation 1, so from equation 1 you have cos x equals to 0, and go to the calculator, otherwise you will see that value of x is 90 degrees. That means we are at the boundary point over here, but it doesn't matter. So in this case, what you can do, because here you can see that cos is 0, either you suppose it is negative or positive, it doesn't matter, but unless or otherwise stated, you can suppose this as positive number. So you know that cos is positive in the first quadrant and is also positive in the fourth quadrant. So what you can do in this case is that if this is 90 degree about this, if you are taking in the at the boundary here, then what you can say in this case, like cos, you know that here in the third quadrant, cos 180 plus 90 degree, okay, plus 90 degree equals to 180 plus 90 degree. That means we are almost here. Or even if you suppose that you are slightly in the third quadrant, then it is minus cos 90 degrees, okay. And here in this case, whether it is plus or minus, in both sides you go to calculator, you check for this value, we'll have both sides 0 equals to 0. So therefore the value of another value of x will be 180 plus 90 degrees, and this is definitely 270 degrees. And this is also possible that if you take the reference of fourth quadrant here, so you know that in the fourth quadrant you could write here 360 degrees and minus this 90 degrees, minus this 90 degrees, and obviously if you suppose this as fourth quadrant, then this is going to be cos 90 degrees, and by using this sort of thing also, your possible value of x is 360 degrees minus 90 degrees, and eventually it is 360 minus 90 is 270 degrees. So did we work for all the values of x for which cos x is 0? Yes. One value is 90 degrees and another value is 270 degrees. Now let's check for this equation 4. So now from this equation 2. So now from equation 2, in the equation 2 you have 4 sin x minus 1 equals to 0, and if you simplify it further, then it is sin x equals to 1 by 4, and then if you transpose this sign to another side, then it is x equals to sine inverse of 1 by 4. Now go to the cat 5. So this angle is 14.5. Now let's think over the value of this sine x. So 1 by 4 is 4 is positive, and you know that sine is positive in the first quadrant and also in the second quadrant. Alright, so the first quadrant answer is already ready over here. Then we check for the second quadrant. In the second quadrant, for example, this angle is 14.5. So in the second quadrant you can take this angle equivalent to 14.5 and then start from here and go till here. So this angle will be equal to 180 degree minus 14.5. So another possible value of x, you will see that this is 180 minus 14.5. Then calculate this. It is 180 minus 14.5, and that angle is 165.5, and if you want then you can check it to the calculator and see that whether or not 165.5 degrees of sine is 1 by 4, that is 0.25. So go to the calculator again, and this is sine 165.5 and close the bracket. Yes, it is 0.25. okay, so this sort of decimal you can see due to the round of things over here, but it is nearly equal to or very close to 1 by 4 that we require here. So therefore you can see now the possible values of x are here according to the given condition of this equation are x equals to, we have 90 degrees, and then yes 270 degrees, and then next we have, you can check it here, it is yes 14.5 degrees, and then it is 165.5 degrees. So while writing the answer, better you write in the, and then finally it is 270 degrees, and these are the answers. Okay guys, once we have done until now, I am sure it will help you solve further problems from trigonometry where cast rule is applicable. So this is all for now, and thank you for your patience.